Since we use both English and metric units, we must be able to convert between units. I'm going to teach you a process called dimensional analysis, and this is a very organized way to go about conversions from one unit to another. In order to use dimensional analysis, we first need to know some conversion factors, so something equal to something else. These here that I have in green are the ones that you must memorize. If you know at least one from mass, length, and volume, you can convert from any metric unit to any English unit, and vice versa. You also need to know that 1 nanometer is equal to 1 times 10 to the negative 9 meters. So I just remember nano negative 9 meters. Now, just to kind of back up from what we have looked at before, I'm going to start with some basic math skills. So one would be, if I have 4 divided by 4, what's that equal to? Well, it's equal to 1. What if I have 500 divided by 500? That's also equal to 1. If I have x divided by x, that's equal to 1. If I have 2x over 2x, that's equal to 1. So, from our basic math skills, we know that anything divided by itself is equal to 1, and that's important when we talk about dimensional analysis. We can also apply this to our conversion factors and use those that we have here. 1 inch is equal to 2.54 centimeters. So if I write it as a fraction here, 1 inch over 2.54 centimeters, well, that fraction is equal to 1 because 1 inch is 2.54 centimeters and 2.54 centimeters is 1 inch. I could also write it this way, and this fraction right here is also equal to 1 because these two values are equivalent. We're going to use our conversion factors in the form of fractions like this so that they are equal to 1 to help us convert from units, because when we have a value, we don't want to necessarily change the quantity of that value. We just want to change the units in which it is expressed. So I'm going to teach you some very basics of dimensional analysis. You may think to yourself, well, I could do it easier or faster my own way. I don't want you to do it your own way. I'm starting with things that are very, very easy because we're going to progress as we go through the semester into using more and more difficult things. And the sooner you learn dimensional analysis, the better your grade is going to be in chemistry. So let's start off with one here, and let's talk about how many seconds are in 3 hours. Well, we would need to know some conversion factors, and I expect you would already know some of these. I don't know how many seconds are in 3 hours. I do know that there are 60 seconds in 1 minute, and I know that there are 60 minutes in 1 hour. So those are going to be the two conversion factors that I'm going to need to use. When you start dimensional analysis, you always start with the number they give you in the problem, and you must write down the units because that's the whole point. We are trying to convert these units, 3 hours, and turn it into seconds. So we're going to take this value and we are going to multiply it by a conversion factor. I don't want to have hours anymore, so I want to make sure that I cancel this out. So I need to have a conversion factor that has hours in it. And that's this one right here. 60 minutes is 1 hour. I'm going to break this down. So I'm going to express this conversion factor as a fraction. Now, how you know which one's on the bottom and which one's on the top, because we want them to cancel out, whatever unit is here has to be here so that then they cancel out. So hour is here, hour has to go here. And in 1 hour, there are 60 minutes. Hours cancel out. Now I have minutes, but they don't want minutes, they want seconds. So I need to use another conversion factor. I'm going to multiply by it. Again, we're in effect multiplying by 1 because our conversion factors are equal. All right, now minute is here. That means, and I don't want minutes anymore, so that means whatever's here, unit is here, has to go here. So minute has to go right here. Now I want to use a different conversion factor. I'm trying to work my way to seconds. Don't use the same one. So 1 minute is 60 seconds. That's the one I want to use here. And so in 1 minute there are 60 seconds. Minutes cancel out. Now I have seconds. That's the only unit that is left, and that is what we wanted, so I'm finished. I'm going to go ahead and write it here so that I don't lose points for not putting units. Now I'm just going to multiply everything on top together and divide by everything on the bottom multiplied together. Here it's pretty easy because everything on the bottom is 1, but that's not always the case. So 3 times 60 times 60 gives me 10,800 seconds. Now, we will be dealing with precision and how to express measurements with the same number of significant figures. That's something I'm going to teach a little bit later, but it has to deal with the uncertainty here. Here this is about 3 hours. But this number looks very, very specific, and that can be misleading. So I have to express my answer with the same level of certainty as the measurement I started with. So in this case, I would end up with just 10,000 seconds. But again, we'll learn those rules later. If you got 10,800 seconds, you did this well. I'll show you another example, still involving time. In this case, what we're going to do is we are going to convert how many seconds, or actually, I have 500,000 seconds, and I want to know how many days that is. So again, I'm going to start with the number they give me in the problem. That's going to be 500,000. And now I'm going to work my way up to days. So we'll need to multiply by some conversion factors. Seconds are here, so seconds have to go here. I can use some of these same that I have here, so I can go from seconds to minutes. That's a conversion factor I know. And we don't want to do mental math when we're going through dimensional analysis because that leads to mistakes. So I'm going to use this conversion factor because 60 seconds is 1 minute. Seconds have to go on the bottom, so this time 60 is going to go on the bottom. 60 seconds is 1 minute. Seconds cancel out. Now I need another conversion factor because I'm working my way up to days. Now I have minutes. Minutes are here. Minutes have to go here. So I want to get bigger because I'm working my way to days. So I will go from minutes to hours. And so there are 60 minutes in 1 hour. Minutes cancel out. Now I have hours. I'm going to work my way up to days, and I do know how many hours there are in a day. So hour is here. Hour has to go on the bottom so that it will cancel, and there are 24 hours in 1 day. Hours cancel out. Now I have days, so I know I'm finished, and I'll go ahead and write my units right here. Now it's going to be everything on top multiplied together divided by everything on the bottom multiplied together. If you do this in one swoop on your calculator, make sure you put one set of parentheses around everything on the bottom. So in this case, it's going to be 500,000 times 1 times 1 times 1 divided by parentheses 60 times 60 times 24 end parentheses. And in this case, my calculator spits out 5.79 rounded. That's how many days. Again, we have to deal with our level of uncertainty here. Because this number doesn't have a decimal, we don't know if it's exactly 5,000 seconds or just kind of an estimation. So we would have to match the number of significant figures. And again, I haven't taught you that yet, but we're going to get to it. And in this case, there's only one. So really, I would say there's about 6 days in 500,000 seconds. But if you get 5.79, you did well on practicing dimensional analysis. There's one last thing that I need to show you. My dimensional analysis doesn't usually look like this. You're going to find chemists can be extraordinarily lazy, and I'm just going to alter this just a little bit. I'm not going to change any of the numbers, but this is what mine looks like. Just faster and easier. Instead of parentheses, I use straight lines. And so it almost looks like a chart of some sort. And you multiply everything on top together and divide by everything on the bottom multiplied together. So I can do that here as well. Not changing any of the numbers, although I did erase some of them. And so that's what mine looks like. We're going to be practicing this throughout the semester, and hopefully we'll have good success with that.